Hey guys, now that you've finished taking your test on surface area and volume, we're going to start our next unit, which is probability. We're going to start with just a single event. So all of the probability we're going to do in this first day is on just a single event. So one pull of a card, one roll of a die, etc. So when we do probability, the first thing that you need to know is it's important to decide if events are mutually exclusive. Mutually exclusive means that no outcomes can be in both sets. In a Venn diagram, the circles would not be overlapping because nothing is shared. Okay, so let's look at more examples and talk about when things are mutually exclusive. Because if they're mutually exclusive, we treat them differently than if they're non-mutually exclusive. Okay, so for example 1, we roll a game dice once. What's the probability that it's even? We can draw what we call a sample space in the form of a Venn diagram. A sample space shows all the possible outcomes. So on a die, if I roll a game die, I can roll a 1, 2, 3, 4, 5, or 6. So in my Venn diagram, I show, okay, here's all my possible outcomes. They're either even, the 2, 4, or 6, or they're odd, the 1, 3, and 5. You'll notice there's no overlap between those two circles. That means these outcomes are mutually exclusive. I can't roll an even and an odd at the same time, okay? So when I go to answer probability, it says, what's the probability it's even? We always do the number of possible outcomes over the total possible outcomes. So in this case, since 3 out of 6 numbers are even, the probability of this happening is 3 over 6, or 0.5, okay? Going a little further with this, it says, what's the probability you roll an even number or a 3? Okay, still a single event though. I'm just rolling that dice once, but I want to know what's the probability it's even or a 3. Because it's or, this is still possible even though these are mutually exclusive. Okay, they're separate events, but it doesn't matter because I'm saying one or the other. In this case, what we do is we do the probability of an even roll, which is 3 numbers out of 6, plus the possibility of rolling an odd number, which is 1 out of 6, for a total probability of rolling an even or a 3. Giving us 4 out of 6. Okay. Okay. Next example. What's the probability you roll an even number and a 3? Now, this is where mutually exclusive comes in. These events are mutually exclusive. It means happening at the same time, and it can't be even and a 3. Okay, if it's mutually exclusive and it's trying to happen at the same time, then my probability is going to be 0 out of 6. Okay, so probability, mutually exclusive, and 0. Got it? So recapping, for mutually exclusive events, non-overlapping circles in a Venn diagram, if the situation is probability of event A or probability of event B, if that's the wording, this or this, then we add their individual probabilities. Okay? If it's the probability of event A and the probability of event B, anytime they're mutually exclusive, we get 0 because they can't both be happening at the same time. That's the definition of mutually exclusive. Now, not every event is mutually exclusive. We also have some that we call non-mutually exclusive. This means the events have an overlap. In a Venn diagram, the circles have an overlapping section. So, for example, we're going to say event A is we roll an even number. Event B is we roll a number less than 3. So I go ahead and I make my diagram. I say, here's event A. All of my possible even numbers are 4, 6, and 2. Okay. A number less than 3 is my event B. That would be 1 and 2. You'll notice that 2 is in the overlap of the two circles because it's both even and less than 3. Okay. Now remember, a dice roll is all the different possibilities in my sample space. So I have 1, 2, 4, and 6 in my circles, which means 3 and 5 come out here in the empty zone of my sample space because they're not part of either event, but they're still part of the possible outcomes. This Venn diagram shows it's non-mutually exclusive because we do have an overlapping section. Okay, so now when we say the probability of event A or the probability of event B, because they're not mutually exclusive, we have to take that into account. So what we do is, once again, we count up all the probabilities, just like before, of event A. There's 1, 2, 3 out of 6, okay? Then we count up all the possibilities of event B happening. 1, 2 out of 6, okay? Then we have to subtract the overlap because that's been counted twice. And I get 4 out of 6. Now, when I look at a Venn diagram, it's really easy just to count and say there's 1, 2, 3, 4 out of 6 that satisfy that, and that's okay. This formula comes in handy though when I don't have a Venn diagram and it's just a word problem where things are overlapping, okay? So remember, if it's non-mutually exclusive, you add event A and event B and subtract the overlap. Now, when it's non-mutually exclusive, if it says A and B, it's possible because there are some overlap, but it's just always going to be the overlap. So 1 out of 6 numbers. Recapping, for non-mutually exclusive events, OR means we do the probability of the first event plus the probability of the second event minus the probability of the overlap, and it's just going to be your overlap. Let's look at a few specific examples. Okay, a spinner has 10 equal areas numbered 1 to 10. If the spinner is spun one time, again, just a single event today, what's the probability the result is less than 8 or a multiple of 2? So the first thing I do is I break it down. I say, okay, the first thing it said was a result less than 8. So here's my event A. 1, 2, 3, 4, 5, 6, 7, all less than 8. Event B, it said or a multiple of 2. So that's my event B. And I have 2, 4, 6, 8, 10. You'll notice that I put 2, 4, and 6 in the overlap because they are both even and less than 8. Now, my sample space shows all possible outcomes. So because it has 10 equal areas, the number I haven't used is 9. That comes out here. And I know that these are non-mutually exclusive events because there's an overlap. Okay. For non-mutually exclusive events, we use that probability of A plus the probability of B minus the probability of the overlap. And then I can just count. So 2, 4, 6, 7 in my A out of 10. 3, 5 in my B out of 10. Minus my overlap, 3 out of 10, gives me a probability of 9 out of 10 that it would be less than 8 or a multiple of 2. Okay, next / last example. Okay, it says in a group of 40 sophomores, 13 are in the band, 18 are on track, and 11 do neither band or track. What's the probability that a randomly chosen student does both track and band? Well, again, we're going to break it down. So if we look at the word problem, it said randomly chosen student does both track and band. So I'm going to just say event A. It doesn't really matter which one you choose for event A and which one you choose for event B. I'm going to say event A is in band and event B is in track. Okay. Now, this one's a little tricky, okay, because it doesn't tell me what the overlap is, and if I add up all of my 3 numbers it gave me, 13 plus 18 plus 11, you'll notice that's more than 40, and there's only 40 sophomores, okay? Because 13 plus 18 plus 11 gives me 42, okay? So what I need to do is I need to start by finding my overlap. So I start with the 11 who are doing neither, if I want, and I put those in there. Then I took the 40 minus the 11, and I said that's 29 students, okay? However, between the 18 and the 13 who band and track, we have 31, okay? So I then subtract, and I get 31 minus 29, which means there's 2 students of overlap. You can do this in whatever order you wanted to. If you wanted to add the initial numbers and say, oh, there's 13 plus 18 plus 11, you'd get 42, and if you subtract that from the 40, there's 2 overlapping still. Okay, so the next thing I'm going to do is I'm going to put my 2 overlap in my Venn diagram because I know that those 2 are being counted more than once. Now I'm going to finish finding the numbers for my Venn diagram. The Venn diagram helps me. So I say, okay, there were 13 who are in band. So I take 13, I subtract the 2 that are in the overlapping circle, and I find that there's 11 that are just in band. So I put them out here. Then I do the same thing with the 18 who run track. I do 18, I minus the 2 who overlapped, and I put the 16 who just do that over here. Now, I can double check if I want. So I double checked, I added 11 plus 2 plus 16. I said, oh yeah, that's 29 students plus 11 students, 40 students. My numbers are adding up, that's a good sign. Now I can answer the question that's being asked using my pretty diagram. So it says, what's the probability that they do both track and band? Anytime it's and it's non-mutually exclusive events, it's just the overlap. So in this case, it's 2 out of 40, which we can simplify to 1 out of 20. Ta-da! All right, that's the breakdown of a simple event occurring. Pay attention, mutually exclusive or non-mutually exclusive.